Hello everyone. I hope you are doing well. Before starting off this video, I just want to share that I have recently started that Oops playlist and I want to launch today the first video and it will launch soon around in the morning itself. And this is the playlist you require for your placement preparation if you are in second year, third year, first year. This if you have basic idea of C++. You must know oops. I explained in the entire video how this series gonna look like, what are you are getting it, notes, practice questions, interview questions, and I will be teaching like very intuitive manner that you cannot gonna forget. Like तुम भूल ही नहीं सकते कि यार वो this is how we can learn things, right? So if you are new to the channel, make sure hit the subscribe button and like the video because we make video around tech, DSA, and AI. So let's get started with today's problem. So what the today's problem says that it says that कंपेयर वर्जन नंबर्स ओके वर्जन नंबर्स भैया कुछ कुछ याद आ रहा है कि अच्छा कुछ वर्जन्स होते थे ना भैया सॉफ्टवेयर्स के वर्जन्स आते थे यस दे आर टॉकिंग अबाउट दैट ओनली given two version strings version 1 and version 2 compare them a version string consists of revisions like बहुत सारे अपडेट्स होते हैं ना कि 1.1 1.2.1 नोड के वर्जन्स देखे होंगे तुमने the value of the revision is the integer conversion ignoring leading zeros. Okay, so what they are saying is, let's say एक version आया 1.01 and 1.001. So they are saying they are same only. You can say they are both are 1.1 versions. Sort of. We can compare them and 1.1 also same only. Leading zeros we can ignore. Okay. To compare version strings, the revision values is left to right order. So what you are saying is it's a lexicographical only, right? Let's say 2.1 version comes and like 1.2 version comes. So obviously 2.1 version बड़ा होगा यार पहले 2.1 version means later आया होगा this comes in later. And this is a basic intuition भैया ये सब समझाने की जरूरत नहीं है ना तो आता है समझ में. Okay, no problem. If one of the versions string have fewer revisions, treat the missing revision as zero. Now what they are saying is इसका मतलब ये है कि let's say कि one has higher version, let's say 1.2.1.2.3, but let's say the other one has fewer versions, 1.3 only, or maybe 1.2 only. So what they're saying is you can treat them other version as zero. You can pad these zeros. If they are not available also, you will be like, okay, okay, this is understood. Then what they're saying is, okay, now after that, comparing the versions, if version 1 comes out to be larger, then return -1, version 1 comes out to be larger, return 1, and otherwise return 0. Okay, we understood the entire problem. Let's quickly go through some examples as well to understand this problem deeply. Okay, it says the 1.2, 1.10. So 1 and 1. See, what we gonna do? We're gonna separate out by dots. Then only we can compare the version, right? So 1 is same. So we'll move to the next thing. Next thing. 2 and 10 we need to compare. Okay, so 10 is larger. Note that we are not going by character. This might be confusion in your head that okay, oh, we are going character by character. 2 is larger than 1. This should be larger. No, 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 no. We are comparing complete number between the two dots. Okay, so it is 10, it is 2. This is larger. That's why -1. Okay. And like this example, I already told you this is a zero padding example that this is like 1.1 and this is also 1.1. That's why both are same. So 0. And here you can understand that again they are padded version again 1.0 and 1.0.000. So what you can say that it can be both are same. It's like one. You can say 1 and 1 also. Now, interestingly, from these example, do you observe observation? What observations you made? See, whenever you solve a problem, go to the constraints, go to the examples, and that's how you started, right? Okay, you got the entire picture in your head, right? Now, what are your key observations? Then you can start the problem. Constraints are very low. Constraint n power n 500. It doesn't matter, right? Don't need to think much about it. Okay, maybe we can do it better. The constraint are this of this problem are low only. So yeah, we'll see an optimal solution only. Okay. So observations. What are the observations? So we are comparing versions. Comparing versions between two dots. Right? Between any two dots. like each version is changing between two dots. Let's say I am saying 2.315.3, right? So how we are gonna comparing? We're not comparing character by character. We're comparing like this group of digit between, and this is the, you can say, the end of the token. That whenever we find this, we just create a new version out of it. Okay, okay, we understood this observation, and then we wanna gonna check the first mismatching version. Okay, between two things, between two strings, that we need to figure out, and that will tell our answer. So okay, so what comes to my mind is, it's very simple, bhaiya, no problem. What we are not gonna do, as we separate out words from a particular sentence with a spacing, we're gonna do the same thing. We're gonna start with our a dummy string, yeah, and then what we're gonna do, we're gonna iterate. We're not gonna iterate on each version. We create two vectors. Like I will write a function so that you don't need to repeat the code. That's why let's say write a function which I give a string version, and then what it will return me. It will return me the vector of, or you can say the array of versions. Okay, okay, bhaiya, fine. How will you do that? A equals to iterate, and now there could be two conditions. Either version of I equals to dot. That means what? We need to stop it. We need to stop. Or version of I. Otherwise, so we keep adding a plus equals to this version of I. Right? This is how we do it. This is how we do it. The standard technique, right? And that's how this helps. Let me just show you. Like let's say 2.31.1.0. So how will you do? Firstly, A is empty. Then we go A equals to 2. Okay. We go A equals to 2. And then when we found a dot, we will reset A to empty. Before that, we'll push this into our vector. So we'll push this into our vector. Then A becomes 3. Then A becomes 3, 1. Then dot. Then we'll push this in our vector. So this is how we are pushing version in our vector. So now tell me one important thing. We did this, and then what we gonna do? We gonna do the same thing for version 2 as well. So let's say the version 2 is 2.31.2.0. So versions will be like 231, 20. And then what you gonna do? You're gonna compare them. Here, here, same. Then move to this, same. This is the first mismatch, and this will give us answer. This is larger. So version 2 is greater than version 1. This is how gonna do it. But now, I hope if you have tried the problem, you must have done until here. You are facing some problem while implementation this stuff, because there are certain edge cases are there. What if the string becomes empty and something like that? And how we compare some concepts that they are not of the same size, and how would we compare? There are a lot of things we need to think about, right? So the best way of doing that is to remove all the edge cases. As an important, another important observation, tell me one thing, that if I got this and if I got this, what I can say? Can I do something, reduce this something, some way? No. Why? Because zero is coming in middle. And zero, I cannot ignore zero now because one is there at the end as well, right? You will be like, okay, yes, bhaiya. But you can ignore this, omit this. Why? This is the end. We already told that we can pad zeros any number of times. Then the zero is useless, which is treated as 2.1. You will be like, bhaiya, why bhaiya? How? This is useful. This is just shitty thing. You are doing just random things. No, 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 no. It will help. It will help when we are comparing many strings. And let's say you get size mismatches, and when you are checking the things, and let's suppose you got same thing. Let's say 2.1 you are getting, and let's say 2.0.1.0 you are getting. And now how would you check between them that they are not same or not? They are actually same. They are actually same. Then you cannot compare on the basis of size. Oh, N2 is larger. Now you can return this is larger. V2 is larger. No. Then you have to check, oh, all are zeros or not. Have to write separate if condition, but you don't need to write that. You don't need to write that. You can omit these. Oh, you can compare. They're same. Now that means we are reduced our strings. That means what ha- what is left? What is left? So we have the optimized version vectors v1 and v2, which cannot contain the last zeros. Now, what is the possible scenarios? Now there are, let's say the sizes of the vectors are n1 and n2. We compare them this way. Okay, we are comparing them one by one, and let's say we found a solution. Then though it's fine, no problem. But let's say we reach the end of the both of the strings. Now, do let me know. Do you iterate on n1 or do you iterate on n2? You guessed it, right? It's like minimum of n1 and n2, right? Why? Because any one of the string get finished, then I will stop somehow. Then we'll check what happens. Okay, we iterate. And if we found a mismatch before that only, and job done, we'll return from there itself. But if does not happen that like that, let's say 2.3.1.1, 2.3.1. Now what we have to do? Now whatever is larger sizer is higher version. Why? Because we already omitted out the zeros. So we don't need to think about zeros. Would have been this zero, then we cannot say that directly. But we already have omitted out zeros, that we are pretty sure who has the larger number of version remaining after the comparison. It's not like larger always. It could happen like this, right? So it's not like this will be larger because this we find previously only before reaching the end. Okay, end is the minimum of them. This is so this is the entire idea. This is an interesting problem. The implementation is interesting. So try to think about all the edge cases and you have seen this problem. So yeah, let's quickly go to the code part. Pretty simple. What we did, we write a function. See, when you have to write the repetitive code, right, for two versions, write the function, right? Why to repeat the code? Clean code. A equals to this. I did that. Why? Because at the end we have to insert again our last version, right? So we have to, after the for loop I write to write a condition, but don't need to do that directly. You can just add a dot. That means at the end also add a operator so that it pushes the last thing, last version as well. Okay. This is the standard things when you are doing some. These are the standard edge cases, right? Then what you wanna do? Iterate from 0 to n. You find a dot. You just push whatever a has and convert it into an integer value, right? It's 0, 0, 1 will also be converted into 1. So you don't need to think about much. Okay. And then it's version of 1. Okay. A is y. And then we just push it and popping out till our back is 0. We are removing zeros, last zero, which I explained, right? Pop back and then until our size is greater than 0. It could happen that the version is like 0. Your size is empty only. That's also fine. No problem with that. Then what you gonna do? You're gonna create two versions, version 1 and version 2. Okay, then you're gonna set sizes and you are gonna run till n1 and n2 का minimum. Then भैया, it's simple. v1 अगर बड़ा होगा v2 से, then we'll return 1 and else we'll return -1 if v1 is less than v2. We won't return equals to instantly because it could happen, right? It could be same for some period of time. Same. We cannot return instantly. We have to iterate. For equality, we have to iterate the entire string. And if they comes out to be same, then we'll return. You cannot write this condition before also, right? It's not like this. You cannot write this before as well. Firstly, let's compare till they are same minimum lengths, and then we will check that. Oh, if they are same, then that means there is no larger. And if n1 is greater than n2, then we'll return 1, else we will return -1. It's a pretty good problem. Implementation wise, slightly thinking. Easy problem. So yeah, and this is it. So I just want to remind you that if you are want to learn oops from me and you're learning from me from last 20 days, this is the best playlist I have discovered. I have curated everything into it. I am putting hard works, and today is the first video coming. So do check it out that as well. Okay. And see you in the next video. Bye bye.